Hello, we're the Blizzard Baja racing team. We build single-seated off-road vehicles, and each year we improve upon the last. This year we have 3 senior design projects.
We have a steering system team working to optimize a previous overbuilt design while improving vehicle responsiveness, a lightweight driveline team working to reduce weight and improve reliability,
and a rear suspension team working to improve upon inefficiencies and reduce the system's weight. The following senior design projects aim to fix these issues.
My name is Christian Hall.
And I'm Abby Jensen. The goals for our steering system are to reduce weight from the previous design by 15%, manufacture 80% of our components in-house, implement carbon fiber parts, and improve the quickness of steering. We chose a rack and pinion mechanism because it's durable, simple, and lightweight. This was our first prototype for our steering box. The top comes off, and here's the tab on the back. After evaluating this design, we came up with the second prototype, which is smaller and lighter, and it also has the rack bushings and the bung for the steering shaft in it. And then finally, we improved a couple issues, and here's our final design.
To improve the quickness of steering, we decided to reduce the steering range while keeping the same input force and the rack travel. The previous steering range was 90 degrees each way, but a driver survey indicated that the steering range should be a little bit closer to 75 degrees each way. A torque wrench was used to determine the input force on the wheel, and calculations were done to determine the pinion diameter, the steering wheel diameter, and the steering range.
To contribute to our goals of manufacturing 80% of our components in-house and implementing carbon fiber parts, we chose to 3D print our steering wheel out of carbon fiber infused nylon filament. This is our first prototype. After getting feedback on this prototype, we came up with this design, which is our final one, and we have 3 different prints of this design, each with a different wall thickness, and we're going to test those and pick one that is the lightest and strong enough.
In addition, we also chose to manufacture carbon fiber steering shaft. It's a 2-piece shaft, so it can telescope to maximize the driver comfort. Since it's telescoping, there has to be holes drilled into it to connect the 2 shafts. These holes caused issues for us, even after completing composite FEA, since composites act very differently compared to metals. So our goal was for the shafts to withstand 90 foot-pounds of torque. This gives us a factor of safety of 1.5 after testing that a human can put 60 foot-pounds of torque. Here is the final carbon fiber shaft that we ended up making, and then here is the final testing rig that we used. This end was clamped into a vise, and then this end was used to input the torque.
Hello, my name is Aiden Flannery,
And I'm Austin Oldham.
and we are part of the Lightweight Driveline Senior Design for Blizzard Baja. The current competition car is the heaviest car designed in recent years. The bulk of that weight comes from the added 4-wheel drive system now required by Baja SAE's competition requirements. The goal of this project is to reduce the weight of the vehicle's driveline while improving upon the structural integrity as well as the performance of the current heavier design. To achieve this, we've decided to replace as many steel components as possible with purpose-built, high-strength, lightweight carbon fiber. This includes, for the first time ever in Blizzard Baja history, a carbon fiber drive shaft.
According to what we measured, the sum of the current car's driveline components comes in at around 57 pounds. We've set our aim to reduce the weight of the driveline by 20% while improving the strength and reliability of the components. A successful design would see the elimination of driveline failure while being lighter and no less efficient at transmitting power than the previous designs. On top of that, we had to complete this project by staying under a $2,000 budget. In the initial stages of the project, we were both new to the possibilities that carbon fiber components could open our team up to, as well as the steps required to get us a working carbon component. We had originally meant to use the process of wet laying our own sheets of carbon fiber fabric into the desired shape for the drive shaft, but we had quickly realized that the errors that could have arisen had we continued further with that design. And with the drive shaft being such a crucial component, we knew we had to look elsewhere. Fortunately for us, we were able to reach out to Dan Lynch at Amelka Composites, who had introduced us to the method of filament wound carbon fiber fabric. The design was shortly finalized after.
During the development, we conducted FEA on the design drive shaft with the forces gathered by the wheel force transducer on the previous competition vehicle, results that were then validated by hand calculations. To minimize failure and driveline inefficiencies, placement of the carbon fiber drive shaft minimizes the angles of the U-joint while abiding by the space constraints of other crucial components. In the end, our carbon fiber drive shaft has a factor of safety of 3 while being 34.4% lighter than the previous design.
Hello everybody, my name is Nick Malley. I'm Colin. And we are redesigning the rear suspension for the Blizzard Baja Enterprise. So the goal of our project is to make a new suspension system for our new vehicle, Gremlin. And we are designing around some pretty major changes from the previous vehicle. We'll get into that.
Yeah, so for the project goals of this project, we decided to try and maintain our factor of safety as the first and foremost to ensure that the part isn't going to fail during race, as we are an endurance race team. We also wanted to reduce weight per unit length, as we have a fixed horsepower number, so we have to reduce weight as much as possible to pick up speed. And then improve ground clearance. We do a lot of jumping and heavy obstacles going over, so it makes most sense to have a lot of suspension travel and have the ground clearance to go over stuff.
Yep. So for our project, we need to design for our own stuff to work, but we also have to make it integrate with other subsystems. So that includes the gearbox, the CV axles, hubs and brakes, bearings, and overall the frame is a pretty huge one since that changed. So we need to make sure that our design is not impeding the functions of other systems while maximizing the performance of the suspension.
So for the weight reduction, overall we started by just slotting stuff. Main culprit here was the sidewalls of the trailing arm itself. We had a lot of material there that we got rid of. I would think almost 60-70%. Big amount of reduced weight while still maintaining the same factor of safety. We also switched to a carbon fiber radius rod upper. That allows us to reduce the weight on that by over 50% while still maintaining strength, and then also slotting the tabs just for a little bit extra. As you can see here with some of our tabs, that just gives us a little bit extra weight reduction while maintaining strength.
Yep. So currently we are working on manufacturing the project right now. There were some setbacks for the team and we had to make some last second changes to our project, but we should have everything on the car by next week. So that'll be exciting. Thanks.